This video is on expected values for discrete data. The mean, or the expected value, they do mean the same thing, of a random variable is the average value that we should expect for x over many trials of the experiment. So our expected value, or mean, is found by using this formula. So what this formula is we've got the sigma, which means the sum of the x's multiplied by the probability of the x happening. So in words, this formula means the sum of all x multiplied by the probability of all x. This example, the random variable y has a probability distribution of p y equals y, which equals 0.125 multiplied by y squared minus 7y plus 14, for y being an element of 2, 3 and 4. Find the expected value of each of the y. First of all, we need to find the probabilities for when y equals 2, 3 and 4, and we've been given a formula to actually do that. So I'm just going to create a little table, and we need to work out the probabilities, and to work out the probabilities we just need to use this formula we have been given. So the probability of that y equals 2 will be 0.125 multiplied by 2 squared minus 7 times 2 plus 14, and that gives an answer of 0.5. We then do that for each of our y values, so we do it for 3 and 4 as well, and when you do that and sub 3 and 4 into the equation, you'll get 0.25s. Now remember, with these tables, the probabilities all should add up to 1, and those do there, which means it's looking like it should do. Now for the expected value of y, we need to use this formula, which is the sum of all the x's multiplied by their probabilities. So we're going to do each one separately. So the first one, we've got the 2 and 0.5. It's the x, or in this case the y, which is a 2 multiplied by its probability. So I'll have 2 times 0.5 plus, we then do the next one, which is 3 and 0.25. Then we have that y, so 3 times 0.25 plus, the last one is 4 and 0.25, so we'll add 4 times 0.25 to the end. So that is the sum of all the y's multiplied by their probabilities. Put that into your calculator and we'll find the expected value of y would be 2.75, or the mean would be 2.75. The other aspect that sometimes can be asked about is whether something is a fair game. The definition of a fair game for the IB is where the expected gain is 0. If there is no input from the player, then we are wanting the expected value to be equal 0. If there is input from the player, then we want the expected value to equal whatever the input is. That will make a fair game. So this example, Hannah and Jason play a game. Jason pays Hannah $4 to play, then rolls a fair standard 6-sided dice. He gets back the score on the dice in dollars. Is this a fair game? What we need is all the probabilities for all of the possible outcomes, which with this one is super easy because it is a fair die, and all our probabilities will just be 1 out of 6. So with this, we are wanting to find the expected value. And if it's to be a fair game, then we want the expected value to equal 4, because that's how much Jason has paid to play the game. So remember to do the expected value, which is just what we did. We do each of our x's multiplied by the probability and add them all together. So we'd have 1 times 1 over 6 plus 2 times 1 over 6 and so on. When we work this out, we get an answer of 3.5. So the expected payout is 3.5, therefore it's not a fair game, as the game is expected to lose 50 cents when they pay in $4. And that is the end of this video.